Hello, and welcome back to another episode of Low Spec Labs. In our last video, we talked about how to install Ollama and how you could use Ollama to run your own locally hosted large language model. Well, in this video, we're going to walk through reconfiguring Ollama and in this video, we're going to walk through reconfiguring Ollama and then installing and configuring OpenWebUI so that it can talk to your Ollama virtual machine. Let's go ahead and get started here. So as you can see on screen, we have our Ollama VM. When it comes to OpenWebUI, you can install it either in a VM or an LXC. It doesn't really matter. But again, depending on if you have a dual socket system or not, you might or might not want to go ahead and install Ollama in a virtual machine. Basically, there's some pinning issues with LXCs versus virtual machines. But if you have only one socket, no need to do that. Or if you're passing through your GPU, also no need to do that. So let's go ahead and get started here. Okay, so we have our OpenWebUI instance spun up. The next step is for us to go ahead and actually get OpenWebUI installed. There's a bunch of different ways to do that. The easiest method is with Docker, or rather a Docker command. But before we can do that, we actually have to get Docker installed. So let's do Docker install. I prefer to go to the Docker documentation just to see how to install it. Let's see, So something you'll notice is that I am running this in a container. So first we're going to want to install sudo, because a lot of these commands use sudo. Wait a few seconds. And we'll also want to install wget and curl. And then we can run that Docker command, right? And as you can see, it says nothing run. Okay, cool. So now what we have to do is copy this script. So what that command basically just did was install the dependencies we need for Docker, right? It also removed any old Docker stuff we might have running. The next thing we have to do is copy this Docker install script and run it. So go ahead and just click copy, go back here, and then we can do a quick nano docker install.sh, and then we can paste the script, and then we want to make that script executable. So we do a change mod u plus x dot, and then we do a quick docker install. And we'll let that run. Then what you're also going to want to do is a quick docker compose, or a quick apt-get install docker compose. We'll also let that run. So the reason we install Docker and Docker compose is because that is one of the easiest way to get Ollama up and running. What you want to do after that is go to GitHub. So if you search GitHub OpenWebUI, it'll basically take us to the page we were just at. But I needed to show you how to get there. And now you'll want to scroll all the way down the OpenWebUI web page. And then you'll want to copy this command right here. To connect Ollama to another server, change the Ollama base URL. All right. So you want to copy this. And then you'll want to open a quick notepad or text editor. All right. So this is the command we're going to need to run. But before we run it, we're going to need to make some quick changes. So for instance, the base URL for Ollama, we'll want to change this to 192.168.2.87. Oh, 201, correction. All right. And basically you either want to change this to the DNS name, this field right here, Ollama base URL. Change that to either the DNS name or the IP address of your Ollama server. And that is it. You go ahead and you hit enter. And Docker is going to automatically do all the building and backend stuff we need to get the OpenWebUI server running. The reason you want to do this is because I went through the trouble of trying to manually deploy it, and it took me about an hour. Versus Docker took me about 5 to 10 minutes. So it's a time savings thing. Now, if you had to deploy this not just for testing purposes, for in production, and I had to scale up, then yes, do go through the effort of learning how to deploy OpenWebUI. Otherwise, just let Docker do its thing and save yourself the time. So we're going to let OpenWebUI finish deploying, and then we are going to go from there. We're going to connect these two right here, and then we're going to send it to commands, and we're going to do some testing and see what type of compute 32 threads, or rather 32 cores and 64 threads gives you. Is it anything useful when it comes to large language models? Is Mr. Low Spec going to have to drop some big money in GPU compute later on this year? We'll see. Depends how useful this technology ends up being to me. So how do we confirm that Open Web UI and Docker is running? Well, we can do a Docker PS. So you can see we currently have something running at port 3000. So let's get the IP address of this host. The IP is 2205. So if we were to do 192.168.2205.3000, something should pop up. Let's see. Oh, connection refused. Did I get that IP right? And by going to HTTP, not HTTPS, you see you now have the Open Web UI. So we'll call this guy LSL, and then into our password here. And there we go. We now have it running. And then we should be able to select our model. So let's go into here. Let's go to settings, admin settings, models, or rather connections. And we can change our Ollama API connection here. So if I were to come into here and get the IP address real quick, this is 2201. So let's see. Let's see what port Ollama is running on. So it's still running locally. So we're going to have to restart the Ollama service. So let's do this. Open Web UI is now configured. We're now going to have to reconfigure Ollama to allow it to talk to Open Web UI. So let's do a quick nano etc system ctl system d system ollama.service. Let's make sure we have environment Ollama host equals 0000, and then we have I see what happened. So first, make sure you have your config spelled correctly, and there we go. So what you want to do is plug into your Ollama host. Once there, you want to use a text editor and go to /etc systemd system ollama.service. Once inside of that service file, you want to add an environment variable. That environment variable is environment equals Ollama host equals 0.0.0.0. You'll then want to save this change. Then what you want to do is force the system to reload its unit file. So you do systemctl daemon reload. Then after that, you'll proceed with a quick systemctl restart ollama.service, and then we can verify Ollama is running by doing systemctl status ollama.service. As you can see, Ollama is now running, right? And it is listing on port 11343 on all interfaces. If you look at this portion of the messaging right here. So what that should mean is we can go back to our Open Web UI instance, 11434. And then you want to hit save. After you that, when you go to new chat, you'll notice now you have a new chat. So let's see what happens when we ask the 14B model how to spell strawberry. I want to see how fast that goes. So it's given time to think. And then the cool thing is we can come on here and you can run a quick BPY top. It can show us how much resources the virtual machine is using, and immediately it's pinned. Then when we go back to Open Web UI, you'll see the 14B model is a little slow, right? And honestly, this thing is still running with, well, the web UI is running on top of the host that's running the model itself, so it's going to be a little unresponsive. Oh, it got that done pretty quick. It says the correct spelling of the word is strawberry. It refers to a sweet red fruit. Let's try something harder. Let's see. How to write a Python So I've asked it to write me a Python script to spell the word strawberry in ASCII. And then we'll go back and we'll see once again it is pinned all the way, maximum GPU usage. And when we look at the host running it, 90% CPU, which means we got just enough resources for the web UI, right? So let's go back to it. Keep our eye on this portion right here. You can see all 60 threads going at it. And then let's see how it's doing. So it's thinking. All right. And I have a feeling that this is going to take a while. So I will be going away for a moment. And I'll let this run and we'll come back when it's done. And I'm back. We'll stop it right there. It generated the code already. So we're going to stop that. And then what I like to do is see performance metrics on it. So let's see. All right, I guess we'll be back whenever it's done doing this. So we have our locally hosted large language model here. And it's done doing its thinking. Let's take a look. This is the result of our question. Again, I don't think this is probably going to work, but it says run. I'm not really too interested in that. What I am interested in is this portion right here. Or rather, the response / tokens a second. So in the large language world, a response or token is one word. So basically, the AI is thinking at one word per second. And it's not really AI. It's, you ever heard of the allegory of giving a million monkeys typewriters 1,000 years and eventually they'd spit out Shakespeare? That's basically what's going on here. We have digital monkeys throwing shit at the wall 1 million times a second. And once a second, they hit the right word. Or rather, they create one word of Shakespeare's Romeo and Juliet. In this case, it took this model 7 minutes to get my answer wrong. This is not strawberry. But at the same time, it almost worked. And that's pretty cool, because that means in about 5 to 10 years, it's going to be very performant. So it's nice to get a quick glimpse into the future. Thank you for watching. If you enjoyed this content, please hit the like button. If you have an opinion, please comment down below. And if you'd like to see more, please subscribe. Tune in next time where we go into Ansible automation and R6 logging. And then after that, we're going to be changing things up and talking about the cloud. More specifically, Azure.